using this biconditional statement, log base b of x is equal to y if and only if b to the y is equal to x, we can replace what y was, log base b of x, for the exponent and get this result. So we can see here that as long as this base and the base of the log are the same, the result is just the input of what's inside the log. So rewriting a different base, say base e, we can write e to the log base e of x is just equal to x because that's what's inside the log. Remember, the base here and the base here must be the same in order for this to be true. Now what we can do is take the n power to both sides. So doing so, we get this. And remember, the log rule, the power rule for logs, says that we can bring this n here in front. So that was shown in a different video. So since we can do that, we can write it like this. X to the n is the same thing as e to the n times ln of x. And why is this useful? Well, because we know what the derivative of e to some power is, and we want to try to figure out what is the derivative of x to the n. So the derivative of x to the n is the same thing as the derivative of e to the n times ln of x, as we've shown here. And remember, the derivative of e to some power is e to that power times the derivative of that power. So the derivative of e to this power is e to that power times the derivative of that power. So of course the derivative of this exponent, this power, with respect to x, would be the derivative of just ln of x, because n is just a constant. So what is the derivative of ln of x? Well, we figured out that the derivative of ln of x is just 1 over x. This comes from knowing the derivative of e to the x and using some other log properties. So knowing that, we can say derivative of this is just n times 1 over x. N was the constant, the derivative of ln of x is 1 over x. And of course, e to the n ln of x, well, that was just x to the n. So we can rewrite this equation like this. So this part is x to the n, and this part, well, the n, we can just write it on top. Now we can rewrite this equation like this. So just moving the n to the front and moving the x to the n on top, we get this. Of course, x to the 1 is just x. And now we can rewrite this equation using another property of exponents, which says that whenever you have a quotient, the powers essentially just subtract. Of course, you can write this or like this. Many times, to not write x twice, we just write it like this, more compact. So therefore, basically, the derivative of x to the n, which is the same thing as the derivative of this, is equal to n times x to the n minus 1. So essentially, the n just comes down, and you subtract 1 from the exponent.